Good day, students. Today we're going to look at another solution to a problem involved in hypothesis testing. So let's get right to it. You are applying for a job as a salesperson that has been posted in two different local car dealerships. The bi-weekly salaries in category reals of the present salespeople for each company are listed below. Is it reasonable to conclude that salespeople in dealership A earn more? Use a 0.05 level of significance and assume the population standard deviations are not equal. Now let's talk about that last part of the sentence there. Assume the population standard deviations are not equal. Not equal. Now, what that means to us, now again, we're assuming normal distributions, we're assuming independent samples, but when the population standard deviations are not equal, it means we can't pool the variances to calculate a statistic. So there's no pooling here, and that's important when you for degrees of freedom. It's important for the statistic we use and so on. So there's no pooling here. We cannot pool them together to get one statistic. We use separate statistics to our calculation. And I'll explain that a little more as we go. Alright, so we have dealership A, dealership B. So this one's dealership A, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So dealership A, the only thing we know about dealership A so far are that it has a sample size of 10, and dealership B looks to have a sample size of 8. Very little is known, right? We don't know the standard deviations of either sample, do we? Or means. So we don't know SX or mean. We don't know that as well. We don't know the mean or standard deviation of the other sample either. So these are all unknown right now. But we do have the raw data, so we can find these. However, now you could do them separately. You could go put all this in list 1 and find the standard deviation and the mean and the standard deviation. But again, we're going to let the calculator do the work for us in using the data function under our test statistic. Okay, let's get to step 1. What is a null hypothesis? What is the alternate hypothesis? Well, let's read again, because the alternate hypothesis can often be found in the wording if you're not sure. Is it reasonable to conclude that the salespeople in dealership A earn more? So when I see that phrase, earn more, right there, I know that mu comparing the means, dealership A is that greater than dealership B. So in other words, A, I'm using comparing the means. A be mu1, dealership B mu2, and the null hypothesis is usually the status quo remains the same, so it'll be less than or equal to. Okay, now a couple things to keep in mind. Again, a reminder that the null hypothesis always contains the equal sign, which it does again in this case, and the alternate hypothesis tells us the tail. It's greater than, so it's a right-tailed test. And right-tailed means the area is going to be 1 minus alpha. Okay, so when we get to the area part, we're going to use 1 minus alpha. Step 2, choose the appropriate level of significance. That's already done for us. We don't have to do that. 0.05. Third step is, what test do we use? Well, we've already probably alluded to it, but it's going to be a t-test, and because we don't know the standard deviations of both samples, so standard deviation is unknown for both. Also, we don't, or for both populations, and we don't know. The numbers are quite small as well. We got 10 and 8, so small sample sizes. Also encourages to use a t-test in this case when sigma is unknown. Number 4 is a decision rule. Now, the decision rule involves finding the critical value, t critical value, right? So let's look at step 4 first. Now, in step 4, we want to find T, and I'll call it CV, critical value, and that involves inverse T and area and degrees of freedom. However, because we're not pooling the data here, this population standard deviations are not equal, then our degree of freedoms is significantly changed. We know that for pooling data we do it this way, right? N2 minus N1, or plus N1 minus 2, right? We use that for degrees of freedom when we pool the data. When you do not pool the data, the formula is significantly different, okay? And lucky for us, Mr. Calculator does it for us as well. And just to show you what that formula looks like, I'll post it here for a second. There's the degrees of freedom formula, and you have to calculate the variance of both samples and so on. So it's a little bit more complicated formula. So rather than use that, we're going to let the calculator do it for us. However, the calculator doesn't do it till you run the step 5, actually find the t-test, run the t-test, right? So I'm going to skip this for a second. So when you're not pooling the data, do step 5 first and go back and do step 4. So I'm jumping over to step 5, and you'll see why in a second. I'm going to run a 2-sample t-test, and I'm going to do a 2-sample t-test where I do choose no for not pooling the data. Okay, now how do we run that test again? So let's go. Well, the first thing I do is put all the raw data in list 1 if I'm using the data function. So I'll put dealership A in list 1, and I'll put dealership B in list 2. Okay, and you know how to do that. So just now, as you see, I've already done it here. So stat, edit, hit enter, and you'll see I have the data already put in list 1 and list 2. Okay, after you do that, so if you want to pause the video now and enter the data, if you're checking this yourself, go ahead and pause and enter that data. So now I'm going to stat, I'm going to run that t-test now. So it's a 2-sample t-test, right? Now the very first thing, notice you have your first choice is your input. Are you inputting the data, or are you just giving me the statistics? If you know the standard deviation and the mean of each sample, you would use stats. However, we're using data, so data is highlighted, and L1, list 1 has dealership A, list 2 has dealership B. Frequency, both should be 1 at this case. So let's just go down now to, now what type tail test are we doing? We're doing a right tail test, so greater than, hit enter, and we're not pooling the data. So say no to pool data. Enter. Now go down to calculate. Alright, notice now we get a t-value, which I'll write down. Let's write that down while we have it there on the screen. The t-value, the calculated t-value is 0.280, and I'll write the p-value down just to be safe, and we'll talk about that after. 392. But look at the third line in your calculator, or fourth line. DF, degrees of freedom, is 15.5. So the calculator used that formula that I showed you and calculated the degrees of freedom for you. That's why we skipped to step 5. Now go back and let's do step 4. Okay? So let's go back and do step 4. So now we have inverse T, area. Now the area is 1 minus alpha. Remember, it's a right-tailed test. So 1 minus 0.05 is 0.95. And degrees of freedom I got from the calculator. So when you don't pool the data, do step 5 first to get the degrees of freedom. Then run back and go back and finish step 4. So how do we do inverse T? That's in distribution. So that's on the vars button, but I hit second first, then vars, and go down to inverse T and enter. It's asking us for the area, which is 0.95, and it's asking us for the degrees of freedom, and you can actually put that in as a decimal, that's fine, and paste. So it's giving us a critical value of 1.75. So now we're right back to where we need to be. So 1.75 roughly up here. All right, 1.75. Well, so what it's saying is this area in here, all this area in here, right, is 0.05. This is alpha. And of course, this is our reject region. I'm going to reject the null hypothesis. Okay? Anything below that, we are going to not reject or accept. Now, some people say do not reject, so I'll write that in this time. Other people say accept HO. Technically, do not reject is a little bit more accurate. There may be type 1, type 2 errors, but lots of people say, for lack of a better term, accept HO. That's fine as well. Okay. Now, decision rule, therefore, is what for step 4? If the test value we get in step 5 is greater than our critical value, because it's a right-tailed test, 1.75, then we're going to reject the null hypothesis. However, we've already done step 5. Our t-value is what? Our t-value is 0.280, which is roughly here on the calculator, or here on our diagram, sorry. Right, 0.280. So it's in the do not reject region or accept HO. So I'll write down accept. Accept the null hypothesis. Okay? Now, accepting the null hypothesis means what? So let's go back to our question. Is it reasonable to conclude that salespeople in dealership A earn more? So we've shown no, right? That's not the case. So no, it is not reasonable to conclude. It is. Okay, let me just jot this down here. That salespeople in dealership A earn more. Okay, so no. It is not reasonable. Alright, so there you have it. That's the solution to a 2-sample t-test given the raw data and not pooling the data. Oh, just to finish off, remember the p-value down here. It's like an extra test, if you would. Some people use the p-test a lot. Probability test. Remember, if p is greater than alpha, then you accept the null hypothesis or do not reject, right? And p here is 0.392, okay, which is definitely greater than 0.05, so we accept. So this is, remember, this is an extra test here for the p-value. Okay, so that's it from me for now. Over and out.